and natural log. So yesterday we talked about how do you solve a natural log with an e, how do you get rid of stuff, and yesterday we talked about how do you find the derivative of e. So if you wanted to know the derivative of natural log, but you don't know the derivative of natural log, get rid of natural log. So we would e both sides. So you get e to the y equals x. So now, what's the derivative of e to the y? However, you're going to use implicit. If you take a derivative of something with a y, it's multiplied by derivative of x. Solve for dy dx. No, but what's y equal to? So let's get rid of the y. E to the ln of x really just becomes, but guess what? The derivative of ln x is 1 over x. That's really not that bad. Derivative of ln x is 1 over x. Ta-da! So, derivative of e to the x was e to the x. However, if x was raised to something other than x, what did we do? Multiplied by the derivative of it. So guess what? If the inside function of ln x is something other than x, what are we going to do? So if the derivative is natural log u, it's 1 over u times du dx, or u prime over u. So I'm going to do a couple of these where I literally set them up as like u prime. dy dx equals u prime over u. And then we will get to a point where you don't have to set it up that way. So my u is x cubed plus 1. U prime, well, what's the derivative of x cubed? So then dy dx is u prime, squared to squared, over u, which is x cubed plus 1. Bam, bam, thank you, man. Told you this was not that bad. Works the same with trig. So inside of natural log is sine x. Derivative of sine is, so dy dx, or y prime, is cosine over sine. Of cosine over sine is she got so mad because she saw the square root. Okay, so square root natural log of 2x implies that I have a chain rule with my problem. Rules don't change though. What's my u? Yep. So u prime is 2. The only difference now is that we have to take the chain rule before the derivative of the natural log. So that's like saying y prime equals 1/2 ln 2x to the negative 1/2 times derivative of ln 2x, which is u prime over u. That's a whole lot of 2's. So 2 over 2 cancel. So I get 1 over 2x square root ln 2x. Now, the next one looks disgusting. Well, we talked about rules yesterday to make it less gross. So don't try to start differentiating and doing like blah, 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 blah. Use the rule of natural log, which says division becomes, yeah. Now it's just two natural log derivatives. So the first derivative is u prime. What's the derivative of x plus 1? So derivative of x plus 1 is 1 over u, which is minus, this is a little trickier, what's the derivative of square root x? I wrote on my paper just over the x, but we can do it over both if you want to. It's over both? And that, and then it's going to put x minus 2 in there. Derivative of x minus 2 is just 1. So there's my u prime all over 2. It's going to clean up really nice because that square root to the negative over the square root to the bottom is really like negative a half minus 1/2. So you get negative 1. So this is going to actually take the square root completely away. The square root times the square root. Go away. So you get 1 over x plus 1 minus 1 over 2 x minus 2. We're done. We're just going to do